Now it's time for Dandi, who's coming from Indonesia, and it's 2 in the morning for him, so we thanks him very much. Dandi Nova Siswoyo, if I'm doing correctly, is from
Yes.
the Mulawarman University. And he's going to present the tomato segmentation on natural background using multi-operation of edge detection and reconstruction. Thank you, Dandi. Floor is yours.
Hello everyone. Allow me to introduce myself. Um, I'm Dandi, an undergraduate student from Department of Informatics, Faculty of Engineering, Mulawarman University, Indonesia. And now I present to you our research topic about tomato segmentation on natural background using multi-operation of edge detection and reconstruction. Um, Let me start by giving you some background about information of this research. Computer technology, especially related to digital image processing, have been widely applied in various fields such as medicine, industry, geology, marine, and agriculture. In agriculture, technology have been implemented to detect disease on the leaves, classification of fruit maturity, and automatic fruit harvesting system. And segmentation is a necessary process related to the implementation of computer vision. In this study, tomato segmentation using image processing. The systems need to be developed for tomato plants because the demand for tomatoes with high quality increase continuously. Tomatoes have high demand because their ingredients are good for human health and rich in nutrients. The contribution of this study develops the varied segmentation methods on the natural background. The method was developed and the localization of tomato until segmented using the edge detection and increase background type to natural background. Well, turning our attention now to the materials and methods. The method consists of several main processes: image acquisition, localization of tomato, pre-processing, segmentation, and evaluation. So as you can see, the image right here, this is the illustrate about the step from the image acquisition until the evaluation. So image acquisition is a dataset consisting of tomato images divided into three maturity levels: ripe, half ripe, and raw tomatoes. The tomato images consist of 50 ripe, 30 half ripe, and 20 raw tomatoes. The resolutions, the origin of pixel, 6944 times 9280 pixels, and the format is JPEG, and the tomatoes complex natural background, and the distance between the object and the camera is 15 centimeter with bright condition, sufficient and even lighting. Next, localization of tomato. So this is the illustrate of localization of tomato. First, reset the origin image from the origin pixel into 640 times 480, and then converting the RGB color spaces to grayscale, as we can see, and the B, and we do the segmentation in this localization using 10H detection, and then continue to dilation and converting dilation into negative images, and reconstruction, dilation and closing, and setting area into raw image. Raw is region of interest, and then we continue to the pre-processing, uh, converting RGB to LAB channel L color spaces and converting LAB to grayscale image. So we can see the pre-processing illustrated in this fig. And pre-processing converting RGB to LAB and converting to grayscale images to continue to the segmentation process. And then LAB channel L, we do segmentation with scan edge detection, and then continue with dilation again, and converting dilation into negative images, reconstruction, dilation, and setting the box area. Still on the materials and methods, this segmentation, we process this LAB channel into gain edge detection. So we can see like this, the comparison of edge detection. There are many operations. This is the first. There are Previt, Robert, Sobel, and Kenny. So as we can see, the best result from our eyes is Kenny. And then dilation, converting dilation into negative images, reconstruction, dilation, and setting the box area. And then evaluation, comparing the image, segmentation result with the ground truth. Next, so now let's move on to result and discussion. This performance of segmentation was evaluated using 3 parameters. SC is segment accuracy, FPE is false positive and false negative, and the formula we can see on the screen right here. And this is the results of a segmentation. So this is the ripe tomato, ripe tomato, and raw tomato. This is the accuracy value, SC, 84.93%, and for the orange tomato is 92.46%, and the green tomato 88.26%. So this is the example of ground truth, and the method was performed in different maturity levels. So in conclusion, let me sum up the main points. So this work aims to develop a tomato segmentation method on the natural background. This method quantitated the pixel number of the area and computed the mean value of each channel from RGB, LAB, and HRSV color spaces with edge detection. This work achieved the highest accuracy value of 89.74%, indicating the method performance based on 100 images, 50 ripe, 30 half ripe, and 20 raw. For future work, this study can be expanded to different segment types of crops other than tomatoes. Thank you.
Thank you very much, Dandi. I really like tomatoes. I really like your work. A work close to the pixels. We are open for some questions from the audience. I do have some questions. Did you try any kind of... there's no too much images of the tomatoes in the paper and in the presentation. You mentioned that the lighting condition of the images is quite good, let's say. But did you try if you have shadows in over the fruits, over the tomatoes? How is the segmentation in that case? Did you try this kind of images? Because in the natural background, I imagine with a minimum wind, the leaves could do some kind of shadows over the fruits.
So I do the segmentation just for the tomato. That's still on the tree. So the background is leaves and everything.
Okay, so the images are quite good images of the fruit of the tomato in that case. You don't have occlusions or the kind of shadow or degradation over the image.
Sorry.
You are assuming that in your image the tomato is well defined. You don't have shadows or occlusions.
I'm sorry, I didn't get it.
Okay, let me make you another question. Are you trying or are you planning to put this algorithm in a robot, in a harvesting machine, for example?
Yes, I hope in the next future there are people use this program of parameters to implement this program into the robot. but this is still the purpose about how to if the compute about artificial how to differentiate between what is the tomato and what is the other objects, just like that,
Okay.
just for the purpose.
One more question. Is there any kind of interest in classify the type, the raw tomato or the mature tomato?
So after segmentation, actually we can continue to the classification, but this project just limited to the segmentation. If you want to
Okay.
continue, it's okay. To classification, it's really possible. I mean,
Yeah, of course, and needed. Thank you very much. Any other questions? Thank you very much, Dandi.
thank you very much.